Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3 for paper 3 October-November 2023, and this is part 1 for questions 1 to 6. Question 1, find a set of values of x satisfying the inequality. This one here giving your answer to 3 significant figures. They said your answer, so that means we have only one. So here they have coupled modulus functions and logarithms. Okay, we know from this one here, if I have the modulus of x, let's say, is less than 1, then this one is the same as saying -1 less than x less than 1. Where does it come from? I can square both sides, and then I have x squared, then less than 1 squared. Okay, bring this one here, we shall have x squared minus 1 squared, which is less than 0, and then when I factorize this one, I can get x plus 1 into x minus 1, all right, which is less than 0. So the critical values, when I equate all of these ones to 0, I'm going to get -1, and then here the positive 1. So since the coefficient of x squared here is a positive, then we have a U-shaped curve, okay? And the two values we have are -1 and then 1. You see that? Now, we want a region which is negative, less than 0. So this is the one below the x-axis, okay? This one is above, and then this one is above. So that means we are going to say -1 less than x less than 1. That is the solution for this one here, okay? So when they give you modular signs on one side, and then is less than something, you should know that it stretches from negative of that to the positive, okay? Now, having picked a leaf from there, I'm going to use the same thing to solve this one that is given here, okay? This one here, I'm going to write it as -0.5, okay, less than, then the 2 power x plus 1, then -2. I have another method where you can split, you consider the positive and then the negative, but this is the simplest you can use, okay? Then less than 0.5. Now we make x the subject. So take the 2 here and also take it this side. When it crosses those signs, it goes there as a positive. So we shall have 2, then minus the 0.5 here, less than 2 to the power of x plus 1, then less than, then 2 plus this 0.5, meaning we have 1.5 less than 2 to the power of x plus 1, then less than 2.5. Then the next thing I can say, of course, to solve exponential functions, we introduce logarithms. So you introduce logarithms everywhere. We shall have natural log of 1.5, then less than the natural log of 2 to the power of x plus 1, then less than the natural log of 2.5. Then, of course, using the rules of logarithms, this one will drop down here. So that means we are going to have here natural log of 1.5 less than, this is x plus 1, and then natural log of 2 here, then less than the natural log of 2.5. Now what I need to do is to make x the subject of the formula. That means I'm going to divide all through by natural log of 2. So we shall have natural log of 1.5 divided by the natural log of 2, then less than x plus 1 less than the natural log of 2.5, also divided by the natural log of 2. Then how can I get x in the middle? Take away the 1. So it comes this way as a minus. It also comes this way as a minus, because inside there it's a plus, all right? So we shall have natural log of 1.5 out of the natural log of 2 will be less than, -1, then less than x here, less than the natural log of 2.5 out of the natural log of 2, and then subtract a 1. So what is this value and this value here? So I have natural log of 1.5, and then down here I have natural log of 2, and then subtract a 1. This one will give me -0.415, and they told us to give our answer to 3 significant figures. So I'll write -0.415 less than x. How about this side? I'll just come where there is a 2, a 1.5, then I put 2.5. So we get 0.322 to three significant figures, 0.322. And this is going to be our answer. And they said give your answer, not answers. So it is just one. That is the set of values for x for that case. Question 2. On an Argand diagram, shade the region whose points represent complex numbers z satisfying the inequalities. This one here and this one here. I've already said that if you have the modular signs on both sides of the equation, then that is a perpendicular bisector. But first we need to get the centers, okay? So what are the centers? We shall have z, create a negative, so that you don't change the meaning, but just create a negative because we need z minus something, okay? Then this is the center that we are looking for. So we are going to have 1, then minus 2i. So that when you open the brackets, this one comes back as a positive and then this one as a negative, okay? Then we have less than or equal to, this one is the modulus of z, then minus, of course, this will be 0 plus 0i. You see that? That means we are having the centers 1, negative 2, and then the other one is 0, 0. Okay, so here we are going to draw a perpendicular bisector, okay, of the line joining points this and this, okay. So let me write this one here. Draw a perpendicular bisector of a line joining 1, negative 2 and 0, 0. Okay, so I may have 1, negative 2 is here, 0, 0 is here. So the points that are equidistant from these two must be lying on this line here, okay, because this one means the modulus, or it means the length. So that means every point that is on this line is the same distance from this center and also this one, same distance like this. So that is why it is a perpendicular bisector, okay. So that is that for that case. And also we know that for a perpendicular bisector, it has to pass through the midpoint of any line segment, okay. So what is the midpoint? Midpoint is going to be 1 plus 0 divided by 2, that will be 0.5. And then negative 2 plus 0, that is negative 2 divided by 2, then you get negative 1. So it must pass through that point there, okay. And then also M1, the gradient of the line joining these two centers is going to be changing y, which is negative 2 minus 0, then out of 1 minus 0, okay, it is that. So M2, in other words, the gradient of this perpendicular bisector is going to be negative 1 out of this negative 2 we have gotten here, okay. So this is 1 over 2. So the change in y, remember I've used this one because for perpendicular lines, M1 times M2 is equal to negative 1. So this is the change in y over the change in x. So that means if I have a point here like this one, then I'm going to move 2 units in the x and then 1 unit in the y. So I find a point, 2 units, then 1 point, 2 units, then 1 point. That is how you find a line and then you draw it, okay. So that is that. Now let's go to this other one here. This one, we are having the modular signs on only one side of the inequality. So that means we get a circle there. So we have z, create a negative. We are having the 2 here, but then there is no imaginary. So I'm going to put 0i, okay? And then less than or equal to 1. So this one is going to be a circle of radius 1, okay? A circle of radius 1 and center. The center is this one here, which is 2, 0. Okay, as simple as that. Now for this case, we are considering if it is a circle, it has to be, the circumference has to be bold, okay, because of the less than or equal. So we are considering the points that are on the circumference of the circle and also inside the circle. So any point that is inside the circle, its length from the center of the circle is less than the radius. You get it? So we look at that less than. And then any point that is on the circumference of a circle is exactly the radius. It's exactly 1 unit from the center of the circle. So we are considering everything there. So we have inside the circle and then on the circumference of the circle. Now I'll go to my sketch and then I put my grid here. Now after drawing the axes, in order to produce a very, very, very wonderful graph or the diagram, it is a sketch, but we are going to draw a circle. In order not to draw a circle that looks weird, I recommend that you use a compass. Okay, so you can get your ruler. Okay, when you get your ruler, then you can actually measure. You put this ruler here, okay, and then you jot the points here. So you do it on the real, and then you also do it on the imaginary. So since the radius is 1, if I use 1 and then 1 like that, and then I take my radius to be this one here, when I draw the circle, it is going to be something very small. Okay, so I can use 2 centimeters for 1 unit for this case. Okay, so I can put here, this is 1. So I do it on the real and then on the imaginary. Now after this, I'm going to draw my circle. So my circle, the center is 2, 0. So I'll come to this point here, 2, 0. That is where the circle is. So I'll pull out my compass. Now when I do, because the radius is 1 unit, remember I took 2 centimeters for 1 unit. Okay, so this circle must pass through this point here, then this one here, then 1 unit above, and then 1 unit down. Okay, so I'm going to get my compass and then draw that. My compass cannot go beyond 3.4. So when you look at this one, when I draw it, it is not going to be so. So what I'm going to do is just to stretch it up to 4 centimeters. Then I just draw that circle. And then after, I'm going to diminish it, okay, such that it fits in here. It has to pass through here, here, then up here and up here. So I'm just going to diminish it. So just like that, okay. Then after, I'm going to plot the centers. So the centers are 0, 0. So there is this one here. You show the examiner that you have plotted this point, 0, 0. And then the next one is 1, negative 2. So 1, negative 2 is actually down here. Okay, plot that point and make it visible. Then from there, we have the midpoint of the perpendicular bisector. Remember, we are supposed to do a perpendicular bisector that is joining this center 0, 0 to this 1, negative 2. So let me draw that small line there, and then I make it dotted because we don't need it. So this one here, make it dotted so that it doesn't interfere with our work. Then I need to draw a perpendicular bisector, but it has to pass through, the midpoint is 0.5, negative 1. So 0.5 is here, and then negative 1 is here. So it has to be here. Then I move 2 units. So when I move 2 units, this is 0.5, then we shall add 1.5. In other words, if this is 0.5, then plus 2, it will be 2.5, okay? So I will move 2 and then 1 unit. So since this one is negative 1, then 1 unit will be just here. So I just need to locate one more point. So this one more point is here where the line is going to pass, okay? So I'm going to make my line pass through this 2.5 and also this one here. Remember, our gradient is here. 2 units in the x, 1 unit in the y, okay? Now, let us draw this line. So I'll draw a line through this midpoint and then the other 2.50. So get it here and then let it pass there like that. But then we also extend it this other side. And when we look at what we were given here, on this perpendicular bisector, it is less than or equal, so it is a bold line. If they had used less than, then it would be a dotted line, okay? Now, we have two centers. We have a center here and then a center here. So, when we are shading, we need points whose distance from this center here, okay, is less than their distance from here, from the 0, 0, okay? In other words, look at the inequality sign. Where does it point? It points to this center. That means you go to where this center is, the side where this center is. So we go to the center of this one, the side of the center, 1, negative 2. So 1, negative 2 is here. That means we go to this side. We have to be this side. So a point that is this side, its distance from this point is actually less than its distance from this other point. That is what this one means. The distance from a point, the distance of a point from this center has to be less than or equal to its distance from the 0, 0. Okay? Now, we are going to consider this one, the side, this side. Now, where actually, then here, we have to consider inside and on the circumference of the circle. So, which region matches the two? It has to be this one here. It is this other side of the line, nearer to the center, 1, negative 2, but it is also inside the circle and also on the circumference of the circle. So the points also on the circumference of the circle, we consider them. So this is going to be our sketch. Question 3. The polynomial 2x cubed plus ax squared plus bx plus 6, where a and b are constants, is denoted by p of x. When p of x is divided by x plus 2, the remainder is negative 38. And when p of x is divided by 2x minus 1, the remainder is 19 over 2. Find the values of a and b. Now here I'm going to use the factor remainder theorem. That if I have p of x here, which is equal to the divisor, let's say it is ax minus b, then times the quotient, then plus the remainder, just like you can get 7 over 2 is equal to 3, then remainder 1, okay? 3 remainder 1. Now, we are going to have, if I get this and I equate it to 0, that means x is going to be equal to b over a. So if I put b over a here, now this one will be 0. So this whole thing goes. That means you remain with the remainder. You see that? So meaning I'm going to get p of negative 2, because when you equate this one to 0, you get that negative 2. Substitute it in the polynomial. So we have negative 2 here cubed, then plus a, negative 2 squared, then plus b, negative 2, then plus 6. Then this one will be equal to the remainder given here, which is negative 38. Now simplifying this one of course is going to be 4a, then minus 2b. All the power of a negative is always a negative, so this is negative 8 times 2. That is negative 16, then plus 6, that will be negative 10. Then when it crosses the equal signs and it adds to this one, it will be negative 28, okay? So we shall write negative 28 here. Then I can divide all through by 2 to simplify this. So it will be 2a minus b, then is equal to negative 14, okay? That is my first equation. And then when we put when we put x here is going to be a half, okay? So p over half is going to be equal to 2 into a half cubed, then plus a, then a half squared, plus b times a half, then plus 6. This one will give us, the remainder is 19 over 2. So 19 over 2, okay? Now, when I get this one, it will be 1 over 8, then times 2, that one becomes 1 over 4, and then plus also here 1 over 4 of a, then plus b over 2, and then plus 6. This one is equal to 19. So I can actually multiply everywhere by 4 because it is the LCM of 2, 1 here, okay, and the 4. So what are we going to have when we multiply? This one is over 2. So here we shall get a 1, here we shall get A, then here 2B, then here 24. Remember, we are multiplying all through by 4. This one will give us a 2 there, then 2 times 19, that is 38. So meaning A plus 2B shall give us, this is 1 plus 24, that is 25. When it comes this side and I subtract, this one will give me 13, okay? So we shall have 13 here. This is equation number 2. Now, these are two simultaneous equations that we can solve. So we have 2 of A here minus B, which is equal to negative 14. Then here A plus 2B. You can use any method you want when you are solving this. I can multiply this one by maybe 2 and then this one by 1. So we shall have 4A. That is when I'm eliminating B, okay? This is 4 minus 2B, 4A minus 2B, which is equal to negative 28. And then this one is A plus 2B is equal to 13. So here I can just add these ones such that the B disappears because you can see that the signs are different. So we can get 5A, which is equal to negative 28 plus 13. That one is going to give us negative 15, okay? So negative 15 here. Then when we divide all through by 5, A becomes a negative 3. And then we can substitute in any of the two. If I substitute, let's say maybe in the second one, we have negative 3 plus 2B. This one is equal to 13. Take this one this side, it becomes a 16. So 2B is equal to 16. And then when I divide all through by 2, our B becomes what? 8. Question 4. Solve the quadratic equation, this one here, giving you answers in the form x plus iy, where x and y are real. Since this one is a quadratic equation in W, I'm going to solve it that way. So by using the quadratic formula, W is going to be minus B, which is a negative 2 here, plus or minus to the root of negative 2 here squared, that is B squared, minus 4, then A, then C. Then we divide by 2A, like that. Now we simplify this one. So W is going to be equal to, this one is a 2, then plus or minus to the root of, this one will be 4, okay? Then I can first multiply what is inside here. So I will have minus 4. So 3 times 3, that is 9. 3 times minus I, that is minus 3I. And then the next one, actually this one is an I. Okay, so I times 3, that will be 3I. And then I times negative I, we shall get negative I squared. But I squared is equal to negative 1. Now, this negative 1 and the negative, that one gives us a positive, okay? So, we shall therefore have a plus here, plus 1. And then we divide by, there is an I here. I don't know why I forget the dot. Pardon me here. So, this one is going to be 2 into 3 plus I here. Now, simplifying this, we shall have 2 plus or minus. Then multiply all through. Of course, this one disappears. So inside here, we are having 10. 9 plus 1, that is 10. Then times 4, that is 40. Okay. Now, after getting that 40, so 4 minus 40, that is root of negative 36. Okay. So we have negative 36. And root of negative 36 is going to be equal to root of 36 times root of negative 1. If I squared is equal to negative 1, that means that I is equal to root of negative 1. So meaning this one is going to be equal to 6I. Okay? Then we divide by 2 into 3 plus I. So this will be 2 plus or minus 6I over 2 into 3 plus I. Then I can I can simplify this. When I divide all through by 2, I can have 1, then plus or minus 3i, then out of 3 plus I. Okay, so W1 is going to be, when I consider, let's say, the plus. Okay, we have 1 plus 3i, then over 3 plus I. So how am I going to solve this? We rationalize the denominator. So we are going to, you can call it rationalizing or realizing. You get this denominator, the conjugate of the denominator. So since this one is a plus, you just change the sign. So it will be 3, then minus I. You multiply it in the denominator, you also multiply it in the numerator. Okay, it's like we have done nothing because that one can disappear. Then open the brackets. So 1 times 3 minus 1, that will be 3 minus I. Then 3i times 3, that one will give us 9i. And then we shall have here minus 3i squared. But remember, I squared is a negative 1. So that means this one becomes a positive 3. Okay. Then down here, which is actually the difference of 2 squares. So I will just have 3 squared, then minus, put the I here, you square it. Now, we shall have here 3 plus 3, you will get a 6. And then plus 8i. Okay. And then here, I squared is a negative 1. So the negative will cancel with this negative, we get a plus. So 9 plus 1, that one will give us a 10. So meaning W1 is going to be 6 over 10, then plus 8 over 10 of I. But we can write it simplified by 2, 3, by 2, 5, then by 2, 4, by 2, 5, just like that. So that is one value. And remember, they told us to write our answers. It wasn't just one answer. Okay, check here, give your answers in that format. So X and Y are real. Now next, here we considered the positive. Okay, now can we also consider the negative? So W2 is going to be equal to 1 minus 3i out of 3 plus I. The same thing we did, 1 minus, we are going to multiply this with the conjugate 3 minus I, also down here 3 minus I. Then we open the brackets, we shall have 3 here, then minus I, 3 minus I, then this one also multiplies with everything there. We shall have minus 9i, then we shall have plus 3i, okay, squared. But I squared is a negative 1, so that means everything there becomes a minus 3. So I will write minus 3 here. Then down here, just like we have seen, I can just put the 10 without wasting time. Then this one disappears with that, and we shall get negative I minus 9i, that one will give us negative 10i, then divide by 10. So meaning W here is just an imaginary number, so it is negative I. That is that. Question 5, find the exact coordinates of the stationary points of the curve, this one here. Now, this is quotient, so we are going to use the quotient rule. However, you should know that when you differentiate an exponential function, okay, we get that power of the exponential, we differentiate it, then after we multiply by that exponential function, just like that. Okay, now we have, if y is equal to u, which is a function of x, over v, which is also a function of x, then that means that dy dx, this is the quotient rule, dy dx will be v du dx, then minus u dv dx, then we divide by v squared. Now, our dy dx is therefore going to be, what is our v? Is 1 minus x squared, okay? This is the v, this is the u. Then we differentiate with respect to x, the u, which is e power 3x squared minus 1. Then subtract u is e power 3x squared minus 1. Then times the derivative of v. Our v is 1 minus x squared. Then after we divide by v squared, which is 1 minus x squared. But then this one here will be equated to 0 because they are talking about stationary points. And for stationary points, dy dx is equal to 0. Now, what do we have here? 1 minus x squared. Okay. Now, when we differentiate what is up here, we are going to get 6x squared. So we shall say 6x, not 6x squared. 6x here, then e to the power of 3x squared minus 1. We are applying this, remember, okay? Then minus, this is e to the power of 3x squared minus 1 times, when we differentiate this one, we shall get negative 2x, negative 2x. Then divide by, this one is squared here, 1 minus x squared, then squared, which is equal to 0. So when I cross multiply, I will see this one gone, okay? So we shall have e to the power of 3x squared minus 1. It is common, so I factorize it. Then I remain with this one here. So I'll have 6x here times 1 minus x squared. And then here, I will remain with, remember this negative makes this one a positive, okay, when they multiply. So we shall have plus 2x here. Then is equal to 0. And then simplifying what is inside the brackets, we shall have this one here, 6x, then minus 6x cubed plus 2x, which is equal to 0. So e power 3x squared minus 1. Okay. Then we shall have 8x, then minus 6x cubed. Then we shall get this e to the power of 3x squared minus 1. We equate it to 0, but of course this one is going to be undefined because there is no number we are going to power with e and then we get a 0. That's why we don't have logarithms of negative what? Numbers. Okay? Logarithm of a 0 is not there, even negative numbers. Then now here we have 8x minus 6x cubed is equal to 0. So what is common? 2x is common. So I will have 4 here, then minus 3x squared, which is equal to 0. Now, that means I will get this 2x here equated to 0. That means x is going to be equal to 0. And then I will also get this one here. I equate it to 0. So 4 is equal to 3x squared. Divide all through. So we shall get 4 over 3. Then is equal to x squared. And then x is going to be plus or minus the root of 4 over 3. Okay. So that is that. And then actually this one can be simplified to plus or minus. Square root of 4 is a 2. Square root of a 3 remains. But since we don't write surds in the denominator, I can just say times root of 3 times root of 3. You see? So this one gives you a 3. And then, so that is the same as writing 2 root 3 over 3. Okay? 2 root 3 over 3. Like that. Now, I need to find the y coordinates for each of them. So for x, which is equal to 0, okay? What is y? So substituting what is given here, it is e power 3x squared. So we shall have e power negative 1, okay? Then we divide by, down we have 1 minus x squared. So it will be a 1 here. So that means this one is going to be e power negative 1. So the coordinates of one stationary point will be 0, then e power negative 1, exact coordinate, okay? Then how about when x is equal to the positive 2 root 3 over 3? So what will be our y? So y, remember, is equal to e power 3x squared minus 1. E power 3 x squared. Since I've gotten this one from this, the x squared is going to be this 4 over 3. Okay, so I'll just put 4 over 3. Then I think there is a minus 1. Yes, there is minus 1. And then down, we are also having 1 minus x squared. So this is 4 over 3. So this one will disappear with that. Then we shall get 4 minus 1, that will be a 3. So e cubed, and then out of 1 minus 4 over 3, that will be 3 minus 4, that is negative 1, okay? So we shall have negative 1 over 3, negative 1 over 3. So this whole thing actually becomes negative 3 e power 3. So that means the coordinates of the other stationary point, the coordinates are, the x coordinate is 2 root 3 over 3. The y coordinate is negative 3 e power 3. Okay, and then lastly, since when so for x, which is equal to negative 2 root 3 over 3, our y, it is going to be the same because it is e power 3x squared. And the x squared, again, when you get this one, you square it, you will get this one here, you see? So I will just also write y is equal to negative 3 e to the power of 3. Okay, it's the same thing. So that means the coordinates of the other stationary point, the coordinates are negative 2 root of 3 over 3, and then negative 3 e to the power of 3. These are the ones, they are 3 coordinates. That is that. Question 6 part A, show that the equation cot squared theta plus 2 cos 2 theta is equal to 4 can be written in this format here. Okay, now we apply the identities. Cot is the same as cos over sine, because cot of theta is equal to 1 over tan of theta, and yet tan is sine over the cosine. That means this one is going to somersault, and we shall get cos theta over sine of what? Theta. So let me put this one off. So we are going to have cos squared theta divided by sine squared theta, okay? Because it is cot squared. Then plus, since it is in terms of sine, cos 2 theta is the same as 1 minus 2 sine squared theta. You can check for it in the list of formulae, it is there. Then minus, this one will be equal to 4. Okay, so opening the brackets, even this one, I will express it in terms of sine. So it is 1 minus sine squared theta using the Pythagorean identity. So over sine squared theta, then plus, this one here will be 2, then minus 4 sine squared theta, which is equal to 4. Now everywhere I'm going to multiply with sine squared theta so that I eliminate this denominator. So that means here I'll have 1 minus sine squared theta, then plus, this will be 2 sine squared theta, then minus 4, this will be sine power 4 of theta, and then this way we shall have 4 sine squared theta. So to make the coefficient of sine power 4 positive, I will take everything this other side. Okay, now 2 sine squared theta minus sine squared theta, we shall get sine squared theta. You see that? Then when it comes this side, it will go there as a minus. So we shall have 4 sine power 4 of theta, which is, now this is 4 sine squared theta minus 1 sine squared theta, so it will be a plus 3 sine squared theta. And then when this one crosses, it will be a minus. So minus 1 is equal to 0. So this is what they wanted us to show. Part B, hence solve the equation, this one. So that means we are supposed to begin from where we have stopped, okay? If we check again, you can see that this one was, this is theta, this is 2 theta, okay? Is it the same equation? We check with this one, it is still theta, 2 theta. So we just bring our quadratic equation, which we have gotten as 4 sine power 4 of theta, then plus 3 sine squared theta minus 1. This one is equal to 0. This is a quadratic in sine squared theta. So I can get my calculator and then I factorize it straight away. Mod, then equations 5 and then quadratic is 3, then 4 here, 3, then -1, then press equals, that is a quarter. So I'll write here sine squared theta. Remember, it is a quadratic in sine squared theta, which is equal to a quarter. Okay. Then the other one is -1. So sine squared theta is equal to -1. But you need to show the examiner that you have solved the what? The equation. So bring this one back. We need the factor from which this root comes. Okay. So it will be 4 sine squared theta. So 4 sine squared theta. Then take the 1 here. It will then be a -1. Okay. Then bring this one here. It will give us sine squared theta plus 1, which is equal to 0. There you have cheated the examiner. Okay. Now from there, of course, this one is undefined because you cannot get square root. We are dealing with real values, so you cannot get the square root of -1. Okay. In other words, you cannot square anything and then you get -1. It is only in complex numbers. So we shall then get sine squared of theta, which is equal to a quarter. And then we take the square roots. So sine theta shall be equal to plus or minus root of a quarter is going to be a half. Okay. Now, we shall have sine of theta is equal to a half. We also have sine of theta, which is equal to -a half. So how do we get theta from here? We get the arc sine of a half, you see? And also here we get the arc sine of -a half. Now, sine is positive in 2 quadrants and also negative in 2 quadrants. So if I draw my circle here, everything is positive in the first quadrant, only sine is positive here, only tan is positive here, only cosine is positive here. We are supposed to move from 0 to 360. So this is 0, this is 90 here, this is 180, this is 270, and then this is 360. So if this is theta here, that angle I can project it down here. Opposite angles are equal, same angle here, then also same angle up here. Now, to move from here up to here, it is going to be this 180 up to here, subtract this theta. Okay, so we shall have here 180. If you are getting the angles from the second quadrant is 180 minus that theta. Okay, remember when you move anti-clockwise, the angles are positive. Then when we move clockwise, the angles are negative. Okay, you are moving in the negatives. Now, of course, to move from here up to here, that is 180 plus theta. That is in the third quadrant. And then in the fourth quadrant, you are moving from here up to here. So you just get the total, then minus this theta here. So meaning, what you are going to have here is 360 minus theta. Now, where sine is positive, it is in the first quadrant and second quadrant. So when I get the calculator and I put in the arc sine over half, theta is going to be 30 degrees. Okay. Now, you will come to this one here and you subtract that 180 minus also that 30 degrees. That is the next angle. Okay. Then the other one, where sine is negative. When you put this one in the calculator will give you a negative answer. Arc sine, our calculator has to be in degrees. Okay. So shift, then mod, mine was in radians. So I put it in degrees. So shift, then the arc sine of negative 0.5. The calculator gives me negative 30. But I don't have the 30. I mean the angles which are negative. Based on the domain which is given to me here, okay, they are positive angles. So what I always recommend is that ignore the negative. When you ignore this negative, you are going to get the 30, which you have gotten from this, okay? Then from there, you go to the quadrants where sine is negative. So sine is negative, okay, in which quadrants? In the third quadrant and fourth quadrant. So how would we get the angles from there? Theta is going to be equal to 180 plus that acute angle, okay? And then 360 minus that acute angle. So this therefore means that our theta is going to be equal to 30 degrees, then 150 degrees, then we have 210, and then 330 degrees. That is that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.